Lesson 4.2, Determining Slope and Y-Intercept. Lesson 4.2, Determining Slope and the Y-Intercept. Determining rate of change and initial value. A linear equation shown is written in the slope-intercept form of an equation. Its graph is a line with slope m and y-intercept b. You read the equation y equals mx plus b, where m is your slope and b is the y-intercept. A linear relationship has a constant rate of change. You can find the rate of change m and the initial value b for a linear situation from a table of values. If you notice, they use the term rate of change. Rate of change is another term for slope. Initial value is another term for the y-intercept. Initial or the beginning value, that's your y-intercept. Rate of change, once again, is also called the slope. All right, and let's take a look at one of our videos based on example 1.
You don't have to drive very far to actually find linear relationships. They're all around us. Let's check out an example and see for ourselves. A car salesperson is paid a monthly salary and a commission for each car sold. And I'm going to show you a table that shows you the commissions. Let's confirm that the relationship is linear and give the constant rate of change as well as the initial value. And then let's see if we can make some sense out of what those things mean. So let's take a look at the table first. So here's the number of cars sold, and then here's the monthly income that the salesperson gets as a commission. So we want to first find out the constant rate of change. So if we want to find the constant rate of change, one thing we can do is take a look at the change in income to, so this is the ratio we're looking at, the change in cars sold.
Okay, before we continue, quick refresher. Change in income, that's your y value. Change in cars sold, that's your x value. So notice how this is y over x. Y over x means rise over the run. Rise over run, that is your slope. Your slope is also called m. And m, or your slope, is the same as the rate of change. So rate of change and slope is the same thing. Rise over the run, which is y over x. Also don't forget, b is called your y-intercept. And the y-intercept is the initial value.
So let's check this out and check out what we get. So between here and here, what we'd see is the change in income is the difference between 5,000 and 4,500. And we look at that in relation to, or that to, the difference in number of cars sold, which is 10 minus 5. And if we work this out, what do we see? Well, this is easy. That's just 500 over 5. And that simplifies to 100. So we see that this ratio gives 100. So we...
All right, now let's pay close attention to what he just did. All right, notice, all we're saying is this is y2, that's y1. This is x2, and this is x1. Now that's important because of our slope formula. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The term I'm using there is sub. Y sub 2. Y sub 2. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And you notice all we're doing once again is rise over run. Rise over run. Rise over run. But it's the change in the y and a change in the x that would give us our slope or our rate of change.
Get 100 right here. So now let's try the next pair. So if we try the next pair, what we see, let me get rid of this stuff right here. The next pair would be to take 5,500 and subtract off 500, or 5,000 rather. So 5,500 minus 5,000, and we divide that by this difference, which is 15 minus 10. But check it out. What is 5,500 minus 5,000? It's still 500. And what's 15 minus 10? It's still 5. And so, in fact, we still get 100. Again, we're seeing this constant ratio, and so that is interesting. That's kind of the linear kind of thing that we normally see. So there's that one. Let's try another one. They're kind of like a fun snack. You just can't stop yourself. Okay, so let's look at the last one. So let's look at the change in income between these two. That's going to be 6,000 minus 5,500 divided by the difference in cars sold, which is 20 minus 15. And what is that? Well, 6,000 minus 5,500 is 500. And 20 minus 15 is 5. And so what we see is, again, we see 500 over 5, which is 100. So all of them produce the same ratio, which tells us that, in fact, we have a linear relationship. We have a linear relationship. There we have it, and that's the slope. So the slope is 100, which means that the rate of change is $100 per car sold. So the rate of change, let me write that down, rate of change, which in fact is exactly what we're trying to find out, that constant rate of change, is equal to $100 per car sold, which means that the salesperson is getting a $100 commission for every car he or she sells. Okay, now, what about that initial value? Well, the initial value we can actually figure out if we actually make a little chart and kind of try to work backwards. So let's make a little chart here and see if we can make sense of this. So again, I'm going to look at, in this table rather, I'm going to look at this table, number of cars sold and then the monthly income, which we know. Let's just confirm that with 10 cars sold, we have an income of $5,000, that's just a repeat, and with 5 cars sold, we have an income of $4,500. Now, let's think about, in fact, let me just scooch this down. Would you mind if I take this table and scooch it down? Tell me you don't mind. I don't mind. Thank you. That's exactly what I wanted to do. So, because what I wanted to do is I want to take a look at how we got from here to here. Now, the way we got from 10 to 5 was just by doing what? Well, we subtracted 5. That's how we got from here to here. And how do we get from 5,000 to 4,500? Well, we see that we subtract 500. And check it out. If you look at the ratio of those two things, negative 500 to negative 5, that's very familiar. Negative 500 to negative 5, when we simplify that, we get 100. So we know that this object is going to constantly repeat because we have a constant rate of change. So if I subtract 5 from the number of cars sold, I know that I always have to subtract 500 from the monthly income. So armed with that, I can actually do this again. So let's now take another 5 and subtract 5 from here. If I subtract 5 from 5, I get 0. Ah, there's the initial value we're looking for. So let's see what the corresponding monthly income is. What do I have to do? I have to subtract 500. Remember, it's always the same. If I subtract 5 from here, I have to subtract 500 from here. That's the constant rate of change. So if I take 4,500 and I subtract 500, I'm just left with $4,000. So the initial value is $4,000. And what does that mean? Well, what the initial value means is that's how much the monthly salary is for the salesperson. If he or she sells 0 cars, he or she will still make $4,000. And so that represents the monthly salary. Then on top of that, they get a commission for $100 per car sold. So maybe I can just write that down. and say that the initial value equals the monthly salary. And in this case, that turns out to be this value, if no cars are sold, which is $4,000. And every time this salesperson sells a car, that person receives an extra $100 for their salary. So check it out. We were able to actually look at this interesting real-world example and break it apart and make meaning of it, find out exactly what the commission is and exactly what the monthly salary is, just because we realize we have a linear relationship. Have fun thinking about the linear relationships all over in your life, and I'll see you soon.
All right, now don't forget that this initial value is called the y-intercept. When x is 0, y has a certain value. When x is 0, y in this case is 4,000. So this is the y-intercept. The initial value is also called the y-intercept.